Let's continue with question 3. So this is getting a little bit more interesting. The tangent at point P to the curve, so there is a point. This is the curve 3x, y equal to 3x minus x squared is parallel to the line y equals to negative 2x plus 1, and you need to find the equation of this tangent. Once again, I'm going to start with the general form. Let the tangent be y equals to mx plus c. Okay, the first thing that you know, well, there are a few pieces of information that you get from this equation. First of all, this tangent is a tangent to this curve, which I don't think we can really use this information yet because I don't know at what x value is the tangent touches the curve. But you also know that this tangent is parallel to this line. Now, if two lines are parallel to each other, they share the same gradient. So first of all, I know that this is parallel. I'll write it out. So tangent is parallel to y equals to negative 2x plus 1. If the tangent is parallel to this line, then we can immediately say that the gradient of this tangent is negative 2. And from that point, we know that y would equals to negative 2x plus c. So we're 50% into solving the question. We just need to find c. Unfortunately, we don't have any other piece of information about the line, so we don't have any point that supposedly lies on the tangent, so we can solve for c. So we need to go back and think about, I have used this information in that, but I haven't actually used the fact that this tangent is a tangent to this curve. So I think I'm going to do that now. If the tangent is a tangent to this curve, then there has to be at least one point where the gradient of the curve equals the gradient of the tangent. So the curve is 3x minus x squared. If I want to find the gradient of the curve, it will be dy dx equals to 3 minus 2x. So this is the gradient of the curve. Okay, well, let's just go to this side. So there will be an x value at which this gradient of the curve equals to negative 2, which is the gradient of the tangent. I'm just going to find that x value. If 3 minus 2x equals to negative 2, being the gradient of the tangent, we're going to solve for x, then you just have 2x equal to 5, which means that x is 5 over 2. So this is another way of saying that this is where at x equal to 5 over 2, the tangent touches the curve. So this is bringing the question back to a very straightforward tangent question. You just need to find the coordinates of this point where x equal to 5 over 2, and then you can solve for c. I don't think my setting out of the working out is making a lot of sense, but anyway, so now that I have found the x value at which the tangent touches the curve, I'm going to find the y value. So when x equal to 5 over 2, you should substitute this into the equation of the curve. I need to create more space, so just give me a second. Okay, what was the equation of the curve? 3x minus x squared. So y is 3 times 5 over 2 minus 5 over 2 square. So we would have 15 over 2 minus 25 on 4. So that's 30 on 4 minus 25 on 4, which is 5 on 4. So the point where the tangent touches the curve is 5 over 2, 5 over 4. And from here, you could substitute the x and y values into the equation of the tangent so that you can find c. 5 over 4 would equals to negative 2 of 5 over 2 plus c, which means we can do a little simplification here. So we have negative 5 plus c. So I cross out the 2 and move it to the other side. 5 over 4 plus 5 would equals to c, which means that c is going to be 25. on 4. So from here I have tangent. I always get into the habit of finally answering the question, negative 2x plus 25 on 4. Okay. Now, because I have the CAS with me, I'm going to check whether my answer is correct. I'm just going to find the equation of this curve, 3x minus x squared, at the point x equal to 5/2 and see whether I get something that actually, well, matches this. All right, so we're going tangent line now. If you're going to type it in, it has to, the line has to be in capital, I think. Minus x squared. Is that a minus? Yes, minus. At the point where x equals to 5/2. Okay, so we have negative 2x plus 25 on 4. So that's exactly what we got. So that's it for question 3.